In this video, we'll briefly explore PatANN, a pattern-aware vector database designed to be massively parallel, distributed, and built to scale. If you prefer a more technical deep dive into the algorithmic and architectural shortcomings of existing vector databases for today's massive AI workloads, and how PatANN addresses each of those challenges, we highly recommend watching the longer but more in-depth version of this presentation instead. Let's begin. You might be wondering, why build another vector database when the AI world already has a few good ones? Let's understand the problem. You probably recognize this face instantly, right? That's because the human brain processes information by recognizing patterns first, details later. That's why our brain is so fast and intuitive. Now, imagine, what if your brain had to look into some database, analyze all the faces you've seen in your lifetime before telling you that he is Tom Cruise? How slow would that be? This is why existing vector databases are slow. They scan every vector one by one, often with approximate heuristics. This slows everything down as skill increases. This is exactly the motivation behind PatANN, to bring speed and scale to vector search. Let's learn how. PatANN introduces pattern probing, a fundamental shift in search methodology. PatANN's algorithm prioritizes structure over brute force matching. The result? 10 times faster than HNSWLib, 3 to 4 times faster than Google ScaNN and Facebook Face, and consistent performance even at very high QPS. But don't just take our word for it. The full benchmark suite is on GitHub if you want to validate it yourself. Let's look at the data in more detail now. As you can see, PatANN achieves high recall while maintaining high throughput, a combination many others trade off. This is another view of the performance metrics. As you can see, PatANN outperforms all major algorithms in QPS, recall, and AUC score. Now let's go through the key algorithms, starting with HNSWLib. PatANN delivers 6.6 times higher throughput, 182K versus 27K. PatANN is 4.5 times faster than Google ScaNN. ScaNN performance drops after 80K QPS. PatANN scales beyond 350K. Against Facebook Face, PatANN is over 10 times faster. Face slows down at high QPS. PatANN stays stable because its architecture is fundamentally different. That raises the question, why was PatANN architected differently? We all know how fast AI is moving, faster than traditional infrastructure can keep up. The sudden AI race pushed many companies into making quick architectural choices that are frankly not scalable. Think about what happened in just the last 2 years. AI exploded. Vector databases that worked fine for smaller datasets suddenly had to handle billions of dense, high-dimensional vectors. Suddenly, those design choices became bottlenecks, outdated and unfit for the demands of modern AI data centers. PatANN was built from scratch to handle this new reality. And these massive performance gains aren't accidental. They come from solving fundamental architectural limitations found in all existing vector databases. The architectural choices PatANN makes, whether it's asynchronous execution, page-aware disk traversal, or multifocal priority queues, are exactly why it can deliver high recall and high QPS at scale, even in environments where other systems start to fall apart. And let's be honest, this kind of architectural reset isn't new in tech, and long overdue in this case. If you're technically inclined to know more about these new architectural choices, or still curious about why a new vector database is necessary, we encourage you to watch the longer but more in-depth version of this presentation, where we explain the architectural trade-offs in existing systems and how PatANN addresses each of them. Let's wrap up with a quick technical summary before briefly covering the deployment model. As we've seen, PatANN has achieved a technical breakthrough with its pattern-aware algorithm and parallel architecture, delivering over 10 times performance gains compared to existing vector databases. It's optimized for both server and mobile environments with full support across Android, iOS, Linux, macOS, Windows, and Python. We're currently working on cloud deployment and replication APIs, along with ongoing R&D into new algorithms like adaptive graph traversal and multifocal priority queues. Like everything else, the deployment approach is also being rethought from the ground up. Most existing vector databases follow the same path, centralized, SaaS-based, and tightly coupled. PatANN is not following that path. Its distribution model is fundamentally different, more open, more scalable, and better aligned with how infrastructure is evolving. We'll share more on that soon. We invite you to try PatANN and share your feedback. You can find fully functional sample code for all platforms in the GitHub repo. Although still in beta, PatANN is already usable in production environments. The APIs are intuitive and simple, and if you've used any other vector database before, you'll find PatANN even easier. There's a brief tutorial to help you get started quickly. Just follow the sample code and API docs. And if you run into any issues, we're happy to help. Just post your question on Stack Overflow with the tag #PatANN or #Masibo. Hope this gave you a clear picture of what PatANN is solving. There's a lot more technical detail on our site. That's it for now. Thanks for listening.